Assalamualaikum. My name is Anis Najaha binti Muhammad Zaid. My student ID is 2025460488. I am from AM1101C and I am from Group 3.
Assalamualaikum and hi, my name is Nurul Alafifah binti Rizwan. My student ID is 20258118848 and I am from AM1101C Group 3.
Hai and Assalamualaikum. My name is Nurul Hanakisila binti Ahmad Zahid. My student ID is 2025892836. I'm from AM1101C Group 3.
Assalamualaikum, I'm Humaida binti Abu Bakar from AM1101C. My student ID is 2025230802.
Introduction of compound interest. Compound interest is a process where interest is calculated on both the original principal and the interest that has accumulated of the previous period. Because the interest keeps building on itself, the total amount can grow at an increasing rate over time. This makes compound interest an important concept in saving loans and long-term financial planning, as even small amount can expand significantly when given enough time. Case Study 1. Problem Statement. Laura had been meaning to travel around the world, so she worked as a freelance photographer for 2 years and now decided to save money for her goal by signing up for Maybank E-Islamic Fixed Deposit iSaving account. She plans to deposit 1,000 ringgit into the saving account for 2 years, and the bank offers an interest rate of 1.8% compounded every 4 months.
First, to determine the accumulated amount at the end of Laura's saving period. Second, to calculate the total interest received by Laura. Third, to calculate the account balance at the end of the saving period when Laura deposit an additional 1,000 ringgit into the same account 8 months after her initial deposit. Fourth, to calculate the accumulated amount at the end of the saving period when the interest rate changes to 2% compounded every 2 months, 4 months after her initial deposit. For result and discussion, first, the principal amount is 1,000 ringgit. Next, the annual nominal interest rate is 1.18%, which is 0.018 in decimal form. The compounding happens 3 times a year, so the value of M is 3. The total time period we are looking at is 2 years. From here, we can calculate 2 important values. The first one is the periodic interest rate. To get this, we take the nominal rate and divide it by the compounding frequency. So, 0.018 divided by 3, which gives us 3/500. The second one is the number of compounding periods. We find this by multiplying the compounding frequency by the time. So 3 times 2, which equals 6 periods.
Objective 1. So determine the accumulated amount at the end of Laura's saving period. The formula is S equals to P multiplied with 1 plus I to the power of N. S equals to 1,000 multiplied with 1 plus 3/500 to the power of 6. S equals to 1,035 ringgit and 54 cents. Objective 2. To calculate the total interest received by Laura. The formula is I equals to S minus P. We will replace S and P to the information given earlier, which is I equals to 1,036 ringgit 54 cents minus 1,000. I equals to 36 ringgit and 54 cents.
Objective 3. To calculate the account balance at the end of the saving period when Laura deposits an additional 1,000 ringgit into the same account 8 months after her initial deposit. For Objective 3, we need to construct a timeline starting from P1 and ends with S. And between P1 and S is P2, which is when the visit happened. P1 equals to 1,000 ringgit, P2 equals to 1,000 ringgit, and S is unknown. The period between T1 and P2, which is T1, is 8 months. To turn it into years, we must divide by 12. And we will be left with 8/12 years. For T2, the term is 16 months, which when turned into years would be 16/12 years, after we divide the 16 months with 12. The K, which is the annual nominal rate, equals to 1.80% or 0.018, and the frequency of conversion equals to 3, meaning the compounding happens 3 times a year, every 4 months. I, the periodic interest rate, equals to K over M. We then substitute 0.018 into K and 3 into M. We will end up with 3/500. Since we have 2 different periods, we will have 2N, or number of interest period. N1 equals to M multiplied by T1, which is 3 multiplied by 8/12. Which equals to 2. N2 equals to M multiplied by T2, which is 3 multiplied by 16/12, which equals to 4. Continue Objective 3. We will be using this formula. S1 equals to P1 multiplied in bracket 1 plus I to the power of N1. Then substitute the correct data into the formula, which will make it S1 equals to 1,000 multiplied in bracket 1 plus 3/500 to the power of 2. So, S1 equals to 1,012 ringgit and 4 cents. Next, we will calculate the P new. use the formula P new equals to S1 plus P2. P new equals to 1,012 ringgit and 4 cents plus 1,000. We will end up with 2,012 ringgit and 4 cents. Lastly, we will use the formula S equals to P new, multiply in bracket 1 plus I to the power of N2. S equals to 2,012 ringgit and 4 cents, multiply in bracket 1 plus 3 over 500 to the power of 4. Therefore, our S equals to 2,060 ringgit and 77 cents. Proceeding to Objective 4, to calculate the accumulated amount at the end of the saving period when the interest rate changes to 2.00% compounded every 2 months, 4 months after her initial deposit. Firstly, construct a timeline consisting of P, the principal amount, and S, the accumulated amount. P is 1,000 ringgit, and S is what we will be calculating. The first term, T1, equals to 4 months, which when converted to years will be 4 over 12 years. The second term, T2, is equals to 20 months. T2 equals to 20 over 12 years. K1 equals to 1.80% or 0.018. The frequency M1 equals to 3. Then find I1 using K1 over M1. It will equals to 0.018 over 3, which is equals to 3 over 500. N1 is calculated by multiplying M1 with T1, which equals to 3 multiplied with 4 over 12. We will end up with 1. Next, K2 equals to 2.00% or 0.02. M2 equals to 6. I2 equals to K2 over M2. Then substitute the right values, which I2 then will become 0.02 over 6. So I2 equals to 1 over 300. N2 equals to M2 multiplied by T2 equals to 6 multiplied by 20 over 12. The value for our N2 is 10. Now to calculate the accumulated amount. First, use the formula S1 equals to P multiplied in bracket 1 plus I1 to the power of N1. Then we substitute. S1 equals to 1,000 multiplied in bracket 1 plus 3 over 500 to the power of 1. The answer for S1 is 1,006 ringgit. Finally, we can calculate the accumulated amount, which is S. S equals to S1 multiplied in bracket 1 plus I2 to the power of N2. S equals to 1,006 ringgit multiplied in bracket 1 plus 1 over 300 to the power of 10. Therefore, our S is 1,040 ringgit and 4 cents.
Introduction of annuity. Annuity is a sequence of payment made at regular interval over a period of time with a fixed rate which is compounded during the period of time between payments. Annuity can be applied when making a purchase of a product through a contract such as deposit or loans. The compounding and payment period can vary from once per month to once in 2 months, quarterly, semi-annually or annually, as long as the period can be defined. The application of annuity for deposit is based on the future value where the saving total amount increase after the set period's end. Meanwhile, the application of annuity for loans is based on the amount of present value, where the present value represents the amount borrowed, which is repaid over time. Therefore, the amount of it will decrease over time until fully repaid. Problem statement for this case study. Tia has been surfing through our website for a new car as her previous one had broken down beyond repair, and she comes across a recon unregistered Alphard. The vehicle has specification and features she finds interesting, and the Alphard also comes with exclusive freebies like 6 years warranty and free service. The car costs 329,999 ringgit, and she plans to make a 10% down payment upfront. The remaining balance will finance through a loan from Bank Islam Vehicle Financing I. The bank offers a 2.5% interest rate compounded monthly, and the loan will be settled in period of 9 years.
The first objective is to determine the amount of monthly payments paid by Tia. Second objective is to calculate the total interest incurred by Tia. Third objective is to calculate the total outstanding balance if Tia decides to settle the loan immediately after making the 84th payment. Fourth is to determine the outstanding areas that must be settled in the next payment if Tia has missed 4 consecutive monthly payments. Result and discussion. First, we must extract the information given in the problem statement. Cost price CP equals to 329,999 ringgit. Down payment DP equals to 10% of 329,999 ringgit, which is 32,999 ringgit and 90 cents. Balance equals to CP minus with DP equals to 329,999 ringgit minus with 32,999 ringgit and 90 cents equals to 296,999 ringgit and 10 cents. Then construct the timeline. The timeline consists of A, which is 296,999 ringgit and 10 cents. The R is unknown. The nominal rate K is 2.5% or 0.025. M, the frequency of conversion is 12. T, term equals to 9 years. The periodic interest rate or I is K over M. which then we will substitute the values. 0.025 over 12 equals to 1 over 480. The number of interest period n is m multiplied by t. After substituting, we will end up with 12 multiplied by 9, which equals to 108.
For Objective 1, to determine the amount of monthly payments paid by Tia, we use annuity formula, which is A equals to R multiplied in bracket to the power of negative n over I. We rearrange the formula to solve for R, which is R equal to A multiplied with I over in bracket 1 minus in brackets 1 plus I to the power of negative n. So we just substitute the value into the formula. By substituting the numbers into the formula, you will get 3,073.81 cents. For Objective 2, to calculate the total interest incurred by Tia is I equal to R in bracket n minus A. By inserting the numbers into the formula, you will get 34,972.38 cents.
Objective 3. To calculate the total outstanding balance if Tia decide to settle the loan immediately after making the 84th payment. With the formula n unpaid equals to n total minus n paid, you will get 24 for n unpaid. Following the formula with a n equals to r in bracket 1 minus in bracket 1 plus I to the power of negative n over I, by inserting the formula with the numbers, you will get 71,884.51 cents. Objective 4. To determine the outstanding arrears that must be settled in the next payment if Tia has missed 4 consecutive monthly payments. First, you need to find your n unpaid first, which means 4 plus 1 equals to 5. Following the formula with Sn equals to R in bracket 1 plus I to the power of n minus 1 in bracket over I, you will get 50,433.22 cents.
So, conclusion for compound interest, if from compound interest, we can learn that money can grow consistently over time, showing that even a small amount can lead to wealth. This growth happens due to interest being compounded on both the principal and accumulated interest. Moreover, we learn how to manage financial planning effectively. We can apply this calculation in real life, which includes savings account, investment, and loans, where our money can increase frequently for longer period of time. So, conclusion for annuity is, from annuity, we learn how to manage consistent payments over time. This method is an efficient tool to increase wealth slowly and steadily over time. In reality, this applies in loan repayment, investment, and education saving over a set period of time. They are very useful in financial planning, especially for big goals. This method encourages saving discipline and long-term financial planning.